Today we're going to continue our discussion on surface area. And previously we talked about finding the surface area of a prism, and we discussed the fact that that would be the area of all of the surfaces. We would use surface area if we were thinking about wrapping something in wrapping paper, covering something in wallpaper, painting something where we need to cover all the outside surfaces. To find the surface area of a cylinder, we want to think about what the net of our cylinder would look like. And we can see here that our two bases are going to be the circles. So we would need the area of our circles. And then we would need the part that kind of goes around our cylinder. Well, if we flatten that out, we come to find that we have a rectangle. So I like to think about when I'm finding surface area for a cylinder, we're really taking the area of our circles plus the area of the rectangle. In our case, we know that we have two circles, and so we're going to have 2 pi r squared. Now, our rectangle, we know the area of a rectangle is base times height. Well, in our case, height of h, thinking about the base is what has to wrap around my circle. So my base is actually equal to the circumference, which is why we express that base as 2 pi r. So base times height is going to be 2 pi r h, base times height. Sometimes kids will get concerned because they may not remember the formula for finding the surface area of a cylinder, but it's definitely something that if you took some time to think about, I think that you could derive that. Let's look at example A. In example A, it says a company sells cornmeal and barley in cylindrical containers. The diameter of the base of the 6-inch high cornmeal container is 4 inches. The diameter of the base of the 4-inch high barley container is 6 inches. What container has the greatest surface area? Or is the surface area the same? We don't know. So we have 2 different containers, one for cornmeal and one for barley. Now we actually are kind of working with the same numbers here. The first one, careful reading, it says the diameter of the base of the 6-inch high cornmeal container is 4. So my cornmeal container is 6 inches high with a diameter of 4. My barley container, the diameter of the base of the 4-inch high barley container. And so the barley container is a little bit shorter with a bigger diameter. This one's a little taller, skinnier. This one's a little shorter, fatter. I'm wondering about the surface area. So we just simply need to plug in our numbers and do some calculating. 2 pi r squared plus 2 pi r h. Now here, if I'm going to compare, I actually might want to think about leaving these in terms of pi. This would be 4 times 2, 8 pi. 12 times 2, 24 pi. This would be a total of 32 pi square inches. My barley container, a little shorter, a little bigger radius, 2 pi r squared plus 2 pi r h. Well, again, simplifying in terms of pi, this would be 9 times 2, 12 times 2, and we can actually see 18 and 24 will give us 42 pi square inches. So it so happens that my container that's a little bit shorter, fatter, is going to have a larger surface area. My barley container, it's about 10 pi. If we had calculated these out, this one comes out to about 100.5 roughly. This one's about 131.9. So we can see about 31.4 square inches difference. What about finding the surface area of a pyramid? Well, again, we know surface area means finding the area of all of our surfaces. When I think about a pyramid, we need the area of the base, which can vary, plus we need the sides. Well, in a pyramid, all of my sides are going to be triangles, right? So we need the area of all the triangles. Again, my base shape may vary, and actually the area of the triangles may vary as well. When I take a look at example B, it asks me to find the surface area of my square pyramid. Well, if this is a square pyramid, I know that my base then is just going to be the 32 times 32. But we need to add in the sides, and on the sides we have triangles. We have 4 of them. We know a triangle is 1/2 base times height. My base of my triangle, 32. The question is, what is the height of my triangle? Is the height of my triangle 30, or is the height of my triangle 34? The answer is 34. The height of the triangle is actually the slant height. The height of the overall pyramid would be 30. That's what we would use if we were calculating volume. But because we're calculating the area of the triangle, we're going to say base 32, height 34. And we have to remember that we have 4 of those triangles. In this case, all of those triangles are going to be equal because I have a square base. And so they all have a base of 32. There may be instances where we would have differences. Let's do a little simplifying here. You could put this all in your calculator at once, or you could break it down into pieces. In the end, when I multiply and I add my 2 quantities together, here I'm going to get 1,024, and here I'm going to get 2,176. When I add them together, in the end, we're looking to get 3,200 inches squared. All right, let's take a look at one more. Lastly, we have the surface area of a cone. When we talk about the surface area of a cone, again, we're wanting to cover all of the surface. We know that we would need the area of the base, which would be our circle. Plus, we need to take whatever is around. Well, wrapped around that, if you open it up and kind of flatten it to the net, it looks like a fan that you would fan yourself. If we slice those into slices and we fit them together, up, down, up, down, up, down, we'd actually start to form a rectangle. The height of that rectangle is actually equal to L, my slant height. The base of that rectangle is actually equal to half of the circumference. So here, we can think about it. It's the area of the circle plus the area of the rectangle. We have pi r squared because we only have one circle. My rectangle base times height, well, the base is half the circumference and the height is the slant height. So it ends up being pi RL. In example C, they're asking me to calculate the surface area and the volume. Really, we just need to take a look at substituting our numbers in. My surface area, pi r squared, I can see I have a radius of 5, plus pi RL, slant height of 10. I don't even need my calculator for this. In terms of pi, 25 pi plus 50 pi, and we would find out that our surface area is 75 pi square centimeters. The volume is going to be a little different. If thinking back to volume, because this is a cone, we need 1/3 area of the base times the height. Well, we know that our base is a circle, pi r squared. The height of my cone actually is not 10. The 10 would be the slant height, but the height would be this dotted line right down through the center. I don't have that information at this point, but I could go ahead and calculate it using the Pythagorean theorem. So we could say that 5 squared plus h squared equals 10 squared. I feel like for the most part that is what most students would do. And if you calculate and you would end up h squared, we would have 100 minus 25, so h squared would equal square root of 75. They'd probably round that off to about 8.7. Now it does happen that this is a 30, 60, 90 triangle, so you could also think of your height as 5 root 3. Either way, we should come out with something pretty close. If I, multiply this by about 8.7, in the end, we're going to find out that we have about 72.5 pi cubic centimeters. Cubic centimeters. Now, that isn't really an exact answer because we did round here. If I wanted to use the exact height of 5 root 3, I could say that I had 1/3 pi r squared times the height of 5 root 3. And you would probably see that simplified to look something like this. 25 times 5 root 3. We'd have 125 root 3 pi, and they'd probably put that all over 3 cubic centimeters. So this probably is what our exact answer would look like. This was more of our approximation. And I would take either one. It's fine with me. Now, if you have further questions on this, please feel free to stop in and see me.